Hey everybody, I want to do another problem. This is problem number 10 from module 7. It has the raw data actually. I want to go ahead and run through this, and it has a confidence interval, which I haven't done yet. So, so I see the raw data here, and I want to copy and paste it if I can in Excel. And I will tell you guys, I always have trouble with this. So it doesn't look like I get it going that way. Sometimes if I go to paste special, I can get it to do things, and there it goes. It did it. Okay, I wasn't certain it was going to happen. It did. Let me show you guys that again. Let's do it once more, and I'll do it slower. So this paste, you see it doesn't work. This paste, you see it doesn't work. So if I go back and I go to this paste special, now this is not HTML, it's not Unicode text, it's just regular old text. And when I convert it to regular old text, it pasted correctly for me. See how it's in each different column, and I have the headers there. I don't know if you're going to get this to work. If you don't get it to work, it's not the end of the world. There's only 10 entries here. I think you can put that in by hand. Okay. That being said, I got it to work, so maybe you can too. Great. All right, let's do the average of this. The mean. So the mean in Excel is average. I'm using my keyboard shortcuts. I'm holding Shift down to make it scroll across, and then I get the average there. Average of 82.5. Cool. By the way, I didn't read the question yet. The mean score of the final exam using the old edition was 75. Now it's 82.5. So we want to use a 1% statistical level. And we get to assume the standard deviation. Assuming the standard deviation means we're using z. Cool. So let's put the old mu in here. The old mu was 75. The x bar, the statistic here, was what I just found. So I'm just going to do equal that cell. There you go. And we know the sigma to be, where was it? 10.6. And we know the sample size here. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So our Z, let's do our SE first. Our SE is the sigma divided by the square root of the n. And our x bar minus mu is this number minus that number. Great, so then I can do my z. My z will equal the x bar minus mu divided by the standard error. So there it is. By the way, if I want to round, there's a couple of ways I can do this. I think I can do round. And I want to round this number. I think I want to round it to 2 decimal places. There you go. So I can copy that and paste it. Let's go ahead and hit check before we move on. I want to know I did that right. Okay, cool. Oh, I skipped question A, didn't I? I should set up my hypothesis test, huh? Studies conducted to determine if a new textbook design is more helpful than the old one. Okay, so this more helpful makes me suggest that I want to have a one-tailed test. I'm not asking if the test is different. I'm asking if the test is more helpful, not just different. So I really want my new, I want the x bar to be greater than the mu, which it was, but that suggests that I want a one-tailed test here. Okay, so then let's go ahead and compute our p-value. So our p-value is that norm dot dist. I want the s there. Norm dot s dot dist. And I'm going to use the original z value. Let's see if that's right. Because I never want to round. Again, I want the tail here. So I'm going to do 1 minus that. So I get a p-value that's just over 1%. Let's go ahead and check those 2 new answers that I put in there. Good. I don't think you should use the rounded z-value here. I really do think you should use the actual z-value. WeBWorK is pretty specific. So then the question here is there sufficient evidence to complain that people do better than 75 on this exam? So this one's a little tricky. We wanted to use a 1% significant level. So normally I say something along the lines of if P is low, the null must go. Well, P is not lower than the significant level. So no, I do not actually have evidence to support the claim that people do better. I'm going to fail to reject that there's any difference from the mean here. Kind of crazy, but this one is a little different. All right, so those are those parts. I need to do the 99% confidence interval here. Let me get my Z star for 99% confidence interval. For my Z star, it's going to be norm.s.inverse. And I got to give it a probability. If I want a 99% confidence interval, I want 0.995. I want 0.5% on either tail. 0.5% on either tail. So this gives me my Z value. And you see my Z was less than my critical Z. Okay, so then my CI, lower and upper, the confidence intervals, the lower and the upper are the statistic minus the Z star times the SE. And if you put all those places in the right spot, this is not bad, then it is the statistic plus the SE times the Z star. And I think I might have done that in reverse order. But those are the values. And we see here that, yeah, 82.5 does fall inside my 99% confidence interval. So that's why I am not able to reject my null hypothesis. I failed to reject. So I'm copying and pasting here with the keyboard shortcuts. I'm going to go ahead and hit submit. And, ooh, I didn't do that right. Ooh, I wonder what I did wrong. Alright, folks, so, sorry. I know what I did wrong. I just did something silly here. When I'm constructing the confidence interval for the mu, the confidence interval for the mu is based on the data that I just gathered. So instead of surrounding the mu, I should be surrounding the x bar. And we did this when we did the, bootstrapping, because the bootstrapping is always centered around what the data actually gave us. So I should be using the x bar as the center of the confidence interval, not the mu. Now, of course, the 82.5 is going to fall right in the middle, but it's about whether this mu falls inside there, and that mu still does fall inside that confidence interval. So I did that backwards. I'm sorry, guys. I do that backwards sometimes. I want you guys to recognize that I don't always get these right the first time, too. Sorry I stopped the video, but I can't make them over like 10 minutes. So I try to watch my time very carefully. So if I make a mistake, I'm pausing. Okay, so your confidence interval needs to be centered around, ooh, I got an achievement. Your confidence interval needs to be centered around the statistic when you're looking for the confidence interval for the mean. So there you go. So it could be 75, the mu could be. So I should have done that centered on the statistic, not centered on there. But again, it's the statistic plus or minus the Z star times the SE. Okay, guys, keep studying hard. You got this.